Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering at Institute of Aeronautical Engineering. In today's class, we are going to discuss about the properties of the coil when they are connected in the series, right? So in the previous class, we have discussed the mutual inductance and self-inductance and also the dot product, okay, and what is coefficient of coupling. And in today's class, we are going to discuss about the properties of the two coils when they are connected in series. Of course, here the properties of the coil when they are connected in series are depends on the direction of the current flowing through these two coils, right? Whether the direction of the current flowing through the two coils is the same or the different with each other, right? So first, let us consider here the direction of the current flowing through these two coils is same, right? So first of all, how the two the two coils are connected in series. So here for our simple understanding, here I have taken, okay, so this is the circuit, okay. So in this circuit there are two coils, the coil 1 and coil 2. So here the coil 1 and coil 2 are connected in series because the end point of the coil 1 is connected to the starting point of the coil 2. So that is how, because we know already how to identify the series and parallel. So I think I no need to explain again. So here these two coils are connected in series, right? So when the two coils are connected in series and the direction of the current in the two coils is in the same direction, because here of course we know already the dot principle that we have discussed. So here in the coil 1 also, what is that, the current is entering through the starting terminal, and the coil in the coil 2 also the current is entering from here. So which means both the current flowing through these two coils is in the same direction, right? So because of that, the EMF produced by or the flux produced by these two coils is also in the same direction, right? So which means here the direction or the sign for the self-inductance and the mutual inductance is same, right? So that's why we can call it as, I mean, if the two coils are connected in like this, then we can call it as a cumulatively coupled. Okay, so the cumulatively coupled is nothing but the two coils must be connected in series and the current flowing through the two coils must be in the same direction, and the flux produced by these two coils must be also in the same direction. So then only we can call it as the two coils are cumulatively coupled, right? Then when the two coils are cumulatively coupled, then what is the equation for the voltage or the current or the mutual inductance, right? So for that, first let me write the voltage, okay. So across the coil, what is that, coil 1 and coil 2, okay. So the voltage is across the coil 1 and coil 2, here it is. So first, because as we know, let us consider the L1 is the self-inductance of the coil 1 and L2 is the self-inductance of the coil 2, and M is the mutual inductance between the coil 1 and coil 2. Let us consider like that. So then here, let me write here the equations for this. So which means first, what is that? Yeah, let me write here. So here let us consider the current is I that they have considered. So then first L1 is the self-inductance produced by the coil 1. So L into di by dt, okay, plus L2 into di by dt plus, okay, actually, or before going to write this equation, let me write one more equation so that you will get understand clearly, or V1 and V2 equation. So which means V1, let us consider here V1 is the voltage across the primary winding and V2 is the voltage across the secondary winding. So first let me write the V1 equation. So V1 equation is, first of all, V1 equation here, the voltage produced across the terminal V1 or across the terminal A and B due to the flux produced by the coil 1, okay, or the flux linking with the coil 1. So which means here it is, which is, let us consider L1 into di by dt plus, because of the mutual inductance also some amount of the voltage will produce in the coil 1. So plus M into di by dt. Then in the second case, V2 is also then here L2 into di by dt, because in the two coils same amount of the current is flowing, so that's why instead of I1 and I2 I am just writing I di by dt, right? So if the same amount of the current is flowing is nothing but the same amount of the flux will produce, because as we know I is directly proportional to the phi. Then here, then now the total voltage V is equal to, okay, yet right here this symbol. Okay, we have already discussed why here it is plus, because the current flowing through in these two coils is same, so that the flux produced by these two coils is also in the same direction. So that's why here we are placing the plus sign. Okay, so then here, then if you add these two, then the total voltage V is equal to V1 plus V2. So here L1 into di by dt plus L2 into di by dt plus, of course, m into di by dt plus m into di by dt. This is 2m into di by dt. So let us consider this is equation number 1, right? Then similarly, R, okay, so from this let me write, okay, R, let me just di by dt, di by dt, di by dt, all let me take the common. So here L1 plus L2 plus 2 into m into di by dt. Okay, so which means actually what is this means? Let us consider here this is case A. Okay, so which means here the total voltage we can also make it as the total what is that inductance, which is LA. Let us consider, so LA into di by dt, which is equal to L1 plus L2 plus 2m into di by dt. So here di by dt gets cancelled. Then you will get LA, which is equal to L1 plus L2 plus 2m. Let us consider this is equation number 1. Then this is the first case. In the first case, when the what is that the coils are cumulatively coupled, then the total inductance LA is equal to L1 plus L2 plus 2m. Then similarly, the differentially coupled. So the differentially coupled here, if you observe these two figures, okay, in the case A, and let us consider here it is case B. So here the current in entering in the two coils is in the same direction, but in this case, okay, one is current is entering and another one is the current is in the opposite direction in the secondary coil, right? So which means here the flux produced by the primary coil and the flux produced by the secondary coil is in opposite to each other, so that the mutual inductance will be also having the negative sign, right? The same way here also, let us write the total voltage V is equal to, okay, the same thing, one is L1 into di by dt plus L2 into di by dt minus 2m into di by dt. Then the same way here, let us consider here it is case B. So the total resistance, the V can be written as a LB into di by dt, which is equal, you just take di1 by dt as a common. So L1 plus L2 minus 2m into di by dt. So here di by dt gets cancelled. Then here LB is equal to L1 plus L2 minus 2m. Let us consider this is equation number 2. Okay, so just make it 1 minus 2, LA minus LB. So if you make it LA minus LB, then here LA minus LB, so which is equal to, so here L1 plus L2 minus 2m, which is minus L1 plus L2, sorry, here it is plus 2m and here it is minus 2m. Okay, then here L1, L2 gets cancelled, here 2m plus 2m, 4m. Then here it is, then m is equal to, what you will get, LA minus LB by 4. So this is what that we can develop a relation between when the two coils are connected in series, right? Or in another words, we can simply write L is equal to L1 plus L2 plus or minus 2m. So here the plus and minus sign is depends on the direction of the currents flowing through the two circuits, whether the direction of the current is in the same or different. If it is same, then here you will get the plus sign, and if it is what is the different, then you will get the negative sign. So this is about the concept of the cumulatively coupled and the differentially coupled circuits. Okay, when the two magnetical coupled circuits are connected in series. So based on this concept, of course, let us discuss some simple numerical problems, right? So in the first case here, the two coils connected in series have the self-inductance of 40 millihenries and 10 millihenries respectively, and the total inductance of the circuit is found to be 60 millihenries. Of course, here they have given the total inductance also, and determine the mutual inductance between the two coils, which means M, and the coefficient of coupling, of course, the K that they ask us to find, right? So anyway, here L1 is equal to 40 millihenries that they have given, and L2 is equal to 10 millihenries that they have given, and total L is equal to 60 millihenries that they have given, right? Now they ask us to find the mutual inductance M. So we know the equation L is equal to what is that, L1 plus L2 plus or minus 2M. So we know L value, L1 value, L2 value, then we can easily find M value, right? But here the concept is we should know whether it is a plus or minus. Then how we can identify plus or minus, because they didn't give us any circuit. So but this we can identify. Okay, so we have to check whether L1 plus L2 is less than or equal to L or greater than or equal to L. So here L1 and L2 is less than L. Okay, so that we can take it as a, this circuit here, it is L is equal to L1 plus L2 plus 2M, right? Then substitute the values here. 60 is equal to 40 plus 10 plus 2M. Then simplify this, then you will get the M value, which is equal to 5 millihenries. Then now we have to find what is the second one, is the coefficient of coupling. We know very well, which is K is equal to M by square root of L1 and L2. Then substitute here, M is equal to 5 into 10 to the power of minus 3 by, and here L1 is equal to 40 into 10 to the power of minus 3 and into 10 into 10 to the power of minus 3. Then if you simplify, then you will get the answer. Let me see here, because I have already calculated. So K is equal to 0.25. So this is the value of K. Very simple, right? Then next problem. Two mutually coupled coils X and Y are connected in series to a 240 volts DC supply. Coil X has a resistance of 5 ohms. Yeah, here typo mistake. Okay, 5 ohms and an inductance of 1 Henry. Coil Y has a resistance of 10 ohms and an inductance of 5 Henries. Right? Of course, because the two coils are connected in series that they have given. And at a certain instant after the circuit is connected, the current is 8 amperes and increasing at a rate of 15 amperes per second. Okay. Then determine the mutual inductance between the coils and the coefficient of coupling. Of course, here also we have to find the same thing, mutual inductance and as well as the coefficient of coupling. Right. So then here, according to this, first what we have to find, the mutual inductance, okay, M. So for that here they have given Lx and Ly, okay, but here we don't know the total, what is that, the total inductance of the particular coil, because in the first case and the second case that they have given, but we don't know the total inductance of the coil. So which means first we need to find the total inductance of the coil, so that the same equation, which is L is equal to, instead of L1, L2, here they have given Lx plus Ly plus 2M. Okay, so from this equation we can find the M value, because we know the value of Lx and Ly, but we don't know the value of L. So then how we can find the value of L? So for that here what we are going to do is, we are just applying the KVL for this particular circuit. So if you apply the KVL for that particular circuit here, then V is equal to I into R plus L into di by dt. So then V we know, which is 240 volts. Okay. So I also we know, which is I think where 8 amperes. So 8 into R, of course, which means both are connected in series, so we can just add up 5 plus 10 plus L into di by dt. So di by dt also we know, because they said the increase at a rate of 15 amperes per second, which means that is the rate of change of current. Di by dt is nothing but, so which is L into 15. So if you simplify this, then you will get the value of L value. So then L is equal to, okay, so here 240 minus 8 into 15 by 15. So then here the L value that you will get here, it is 8 henries. Now substitute these value. So 8 is equal to L1 1 and plus L2 is 5 plus 2M. Then if you simplify this, then you will get M value, which is equal to 1 Henry. See here, as I told you before, here you no need to remember the equations. You just understand the concept. So automatically you can write or you can develop the equations by yourself. Because here, as you can see here, we know the basic concept of KVL and KCL. We just applied the KVL. Okay, then we got the value of L. Okay, so from that we know this equation. So from this we are just finding the value of the mutual inductance. Okay, like that. If you understand the concept, then automatically the equations you can write. You don't need to by hand or you don't need to remember the equations, right? Then M is equal to 1 millihenry. Of course, anyway, the second problem that they ask us to find here, it is the mutual inductance. Yeah, the self inductance of each coil and the mutual inductance of each coil. Okay, so sorry, this one. Yeah, the coefficient of coupling. So here the coefficient of coupling, here it is K is equal to M by square root of L1 and L2. So M is equal to here 1 and square root of L1 is 1 into 5. Then you will get finally 0.447. That is the value of K. K is equal to 0.447. See, simple. So now we are going to discuss about the another problem. Here this is little bit different from the previous two problems. Let me read the problem. Two coils are connected in series and their effective inductance is found to be 15 millihenries. So effective inductance is nothing but the total inductance. And when the connection to one coil is reversed, okay, yeah, that they are saying already the connection of the one coil is reversed, and the effective inductance is found to be 10 millihenries. If the coefficient of coupling is 0.7, then determine the self-inductance of each coil and the mutual inductance. Right. So first let us write the given data. Okay, so that we will get to understand actually what they are giving, and based on that also we can estimate the circuit. Right. So first what they are given, of course, the same equation here also we because L is equal to L1 plus L2 plus 2M, but here we don't know the value of L1 and L2. Okay, so for that here, but we know another one is M is equal to another equation, which is M is equal to K is equal to M by means M is equal to K into square root of L1 and L2. So from these two equations, then we are going to find the value of L1 and L2. So nothing, because by these two equations we are just to make it one equation in terms of L1 or L2. Okay, so from that we can find the value of L1 or L2. So here that they have given LA, which is equal to 15 millihenries. Okay, and LB is also that they have given, which is 10 millihenries. Because LA means when the two coils are connected in, or the current flowing through the two coils is same, and LB means the current flowing through the two coils is different from each other. So that's what it's mean. Okay, LA and LB. So which means here first LA is equal. Let us write this one LA. So which means 15 is equal to L1 plus L2 plus instead of here M, I am just writing again this one in terms of L1 and L2. Okay, so which means 2 into K, right? So first one is positive because both are in the same, and this is, let us consider equation number 1. In the second case, here it is 10 is equal to again L1 plus L2 plus, not plus here, it is minus, because that they have said when the connection is one coil is reversed. So minus 2K into L1 and L2. Right, this is equation number 2. So here by simplifying these two equations, because this equation is in terms of L1 and L2 and this equation is also in terms of L1 and L2. right? So two equations are there and two variables are there. If you simplify this, then you will get the value of L1 and L2, right? Because I'm not solving here because it is very easy. By using calculator also you can find. So then you will get the final value of L1, which is equal to, let me write here because I have already derived, 0.26 Henries, which is L1, and L2 value here it is 12.24 millihenries. Okay, no, so 12.24 millihenries. This is L2 value, right? So then L1, L2 values that we have calculated, then you can find mutual inductance, the mutual inductance. So M is equal to the same way that you can write, because from this equation we can't find the M value because we don't know the value of K, right? So that's why, because we in this class we have already derived one more equation for the M. Yeah, this one. M is equal to LA minus LB by 4. So by using this equation you can find the value of M. So LA minus LB by 4. So you know the value of LA and LB. So you can directly substitute here. Then you will get the M value, which is called 1.25 milliamperes. Right. So here LA is 15 into 10 to the power of minus 3 minus 10 into 10 to the power of minus 3 by 4. So that you will get this value. This is M value. Right. So this is how you can find the mutual inductance. Right. So this is how the concept of the cumulative coupled circuits and the differentially coupled circuits and some numerical problems based on these concepts. Thank you. So in the next class we will discuss about the next topic.
Like, share and subscribe. Hit the bell icon for more updates.